So
live streaming is on.
So hello everyone, welcome to the MuseScore Café, and I'm hoping that we are broadcasting. We're trying something new today, so I'm going to give it a few seconds to make sure, but my name is Marc Sabatella, Director of Education for MuseScore, and we have with us today, so I'm going to give it a few seconds. There we go, that seems like it's working. Let me turn my sound down over here. There we go. Okay. So we are. So I have my guest here, who I've told you would be joining us today. This is Kumar Kartikay. So say hello.
Hello. Hello, everyone. Good morning.
Great. So what typically happens here is we'll have, anywhere from half a dozen to more people watching live, and then lots more people, hundreds more, end up tuning in over the coming week or two. Anyone who's tuned in live, you should be able to participate in the chat and ask any questions here. But let's talk about what we're going to be doing here. So I've talked in the past about the Google Summer of Code, and let me zoom. Oh, I have the backwards camera thing going on here, but that says Google Summer of Code. It's this Google Summer of Code is a program sponsored by Google, obviously, where they choose, or they work with open source software organizations like MuseScore, and a certain number of organizations get chosen to participate. You have to apply as an organization to participate, but we've applied every year for the last, 10 years or so, and we've been accepted every year except maybe one or two. So we're usually part of the Google Summer of Code, and then Google then sponsors students, like college students. You have to be actually enrolled at a university somewhere to work on open source software. So we've had in the past, each of those, 7, 8 years that we've participated, a handful of students, anywhere from 1 to I think 4, maybe was the most we had. Students who would work on MuseScore, actually developing some of the software, and some of the features that we all now take for granted were actually developed as part of Google Summer of Code. Some of the things that I can think of that have happened as a result of this: one is the real-time MIDI input feature was implemented by a Google Summer of Code student. A lot of the accessibility work that I'm talking about a lot here, as far as our support for screen readers, was implemented as part of that. A swing playback, chord symbol playback, just tons of features were implemented as part of this. But aside from that, not all of the Google Summer of Code projects are necessarily about user visible features. Sometimes it's about streamlining how things are done in the code. One of the more important ones there was some changes that were made to how we actually save files, so that it would make creating automated tests easier, and some other things like that. And eventually this also became a score comparison tool that I've showed, and that ended up being a useful byproduct of some of those changes. So anyhow, Google basically sponsors the student for the summer and pays them a stipend to work on open source software with a mentor. And I've been a mentor for this in the MuseScore project for a number of years. And I am this year also. The student I am mentoring, Isaac Weiss, will be on in a few weeks. So that's enough of me talking for now. I've told you what the Google Summer of Code project is about, but now I want to actually turn over to Kartikay to talk about how you got involved, how you found out about Google Summer of Code, what made you choose MuseScore as the project to work on.
Right. So the institute that I'm studying in, that is NIT Hamirpur, it has so every year about 5 to 10 students from our institute get selected in Google Summer of Code. Usually there's a lot of competition for it too. And so basically, last year I was at one of the talks that some of my seniors were giving to the juniors. They were just telling us all about the Google Summer of Code program, and they were telling us that what you need to do in order to get selected and what kinds of work you have to do. So I went to the Google Summer page, and I saw that one of the organizations was MuseScore. And actually, I was familiar with MuseScore already because in the past I had interest in music, especially in visual music. And so I was quite excited about working for MuseScore. So last December, I started working on MuseScore on a very small bug fix. It was something related to a file handling code, and since then I contributed some bug fixes, and I also worked on a small automated test that had something to do with the accessibility feature in the palette, and so that was basically how I found out about MuseScore and Google Summer of Code.
Nice. So I know what the Google Summer of Code program looks like as a mentor, and I have some idea of what it looks like as a student, but I'm going to ask some questions that I think I sort of know the answers to, but other people might not. The process of how you get chosen, do you first have to apply to Google just to be even included in the program? Is that true? You have to give all this information saying, yes, I am a college student and here's my university and all that kind of stuff?
Yes. So the first thing that you have to do is you have to go to the Google Summer of Code website and you have to get registered there. And they ask us for some kind of proof of enrollment in a college or a university. So basically, you have to just show them your ID or some letter stating that you are enrolled in a college. And after that, you have to just start working with the organizations and talk to the mentors, uh, submit some bug fixes or just write some code for them, and then you have to write a proposal and you have to submit it in the Google Summer of Code website, and then uh, and then basically the mentors will review it, and they will send the reviews to Google. Perhaps I don't know what exactly happens after that, but after that, Google announces the results.
Gotcha. Well, I'll talk a little bit about that because probably I'm thinking that people watching this are just curious about the whole process. What happens from our perspective is that we get all these proposals submitted from students, and the proposals that are submitted, many of them are from students that we've basically never heard of before. In other words, in any given year, we might get 30 proposals and maybe 10 of them, 15 or whatever, are from students who never engaged with us at all. They never had any discussions with us. They never fixed any bugs in MuseScore during this whole process. Because there's like this time period of, I forget what it is, a couple months, right? Where you're developing your proposal, kind of getting to know the organization. And I should say that we pretty much just reject those proposals out of hand. If a proposal comes from someone who has not been involved in the project during that period, we pretty much don't even look at it. It's a slight overstatement, but it's basically, off the record, that's basically true. So what ends up happening is then we have a set of people like Kartikay here who did participate in doing some bug fixes and participating in the developer chat and maybe forum posts, maybe other things that we're getting involved. And so we come to know who this person is and how well they kind of fit in, and whether they can actually produce good code. So we learn about the submitter that way. But then the day that proposals are actually submitted or finalized, we look at the actual proposals, And usually we know what their proposal is going to entail. We've been kind of coaching them on this, but then we just sort of all sit down and read all the proposals, and then we discuss amongst ourselves, we being the other mentors, the people who are on the kind of project team as far as that goes. And we decide, it's this whole complicated process where first we decide how many students we would like to accept. And then we tell Google that number. And then you tell them two numbers. You tell them, well, we'd like at least this many, but not more than this. And then Google picks a number somewhere in that range, or they just make up their own number. But they're not going to give you more than you think you can handle. Then once Google tells us how many slots we have, then we make the final call. So we might say, well, look, we had 5 really good proposals. We would take as many as 5, except that we only really have mentors for 4. So I guess we'll take a maximum of 4. And then we wait and find out how many slots we get from Google before we make the really hard decisions of which to extend invitations to. But then some people submit proposals to multiple projects. Like, did you submit to anything else other than MuseScore, Kartikay?
No, I didn't submit other station, but I submit 2 to MuseScore. One of them was lyrics editor.
Right.
The one that that.
Okay, so I think you're cutting out from my end, and I'm probably cutting out from your end, and that's just life in this age of video conferencing. But what I heard you saying is that you submitted 2 proposals, right? You submitted the one that we actually accepted, and another one on Lyrics Editor, both to the MuseScore project. Well, the rules of Google Summer of Code allow people to submit to multiple projects. Good. So some people do submit proposals to multiple projects, and so then we might accept a proposal, but then the other project might also accept a proposal from the same person. So before the results are announced, Google goes through and figures out, oh, wait a minute, this person was accepted by 2 different projects. Let's work out which one, because you can only do one at a time. So there's this whole process of this juggling around like that, where in the end we finally decide, okay, these are the people who we have chosen. And this year we ended up with three slots, they call it. So 3 students, and we chose the 3 students we wanted, and they were all accepted, and because none of them had submitted to any other projects, or at least weren't accepted by other projects. I don't think they had submitted to any. And so we have 3 projects here. And so we're going to hear today about Kartikay's project. And you'll hear more about it. It's one of these that's mostly about dealing with the internals of the code, but in ways that I think we can show how they're going to be useful to people. One of the other projects that you're going to hear about next week is from a guy named Sergios, who is going to re-implement the one feature that we kind of lost going from MuseScore 2 to MuseScore 3, which was albums, which is a way of combining a lot of different scores. And we've been sorely missing that ever since MuseScore 3 came out. So he's going to implement it again, but in a much better way. So it's going to be an improved version. And so that'll hopefully be in MuseScore 4. And then the third student is Isaac. And Isaac is going to be doing a series of changes that mostly have to do with multi-measure rests and multi-measure repeats. And so they have to do with the actual layout of your score and the way your score looks, and when you're dealing with ensemble music mostly. So anyhow, we'll have each of these people on it on different weeks. So yeah, at this point, let's talk about what your project is. So Kartikay, you just feel free to just explain in your own words what you're going to be doing.
Right, I'll just try to explain my project. I'll try to not make it too technical so that even non-programmers can understand it. And I just wanted to send you a few screenshots before I start. So
yeah, so just try one more time, just for grins, to see if the screen share works. We tried to do a screen share earlier, it didn't work, but let's just try again. Won't hurt, right?
Okay, let's just try it.
just because maybe it'll broadcast live even though I couldn't see it is my theory.
So is it working now?
So on my screen, all I see is an icon telling me that you are doing a screen share, but it's not showing up yet. The live stream, it's kind of the same story. So unfortunately, how about if you, yeah, is your camera on also right now? Or did it turn itself off?
My camera is off right now.
Okay. Try turning it on. I'm just
Just a
curious what'll
second.
happen if you turn it. Okay. Oh. Oh.
Right, just a
I think I
second,
see
please.
it. I think I
Did it
see.
work?
I think I see your screen. I think that's your screen.
Um,
Yes. What'd you do?
okay, right. So
What was the magic so that I know for the future?
I just switched on my camera. Probably it was just that I had to switch on my webcam.
Wow, that does makes no sense, but I'm glad it did it. All right, we're seeing your screen. Yes.
Right. All right. So I'll just try to start explaining about my project. So basically, what I am working on is like whenever you when you have a score in MuseScore, you have to store it in the memory somehow in the code. Like so, in C++ code, I think some of you would have heard of objects and classes. So in C++, basically all the things that are stored in memory, they are in some kind of objects, and these objects are connected together by something called as pointers, and these pointers are basically like links to other objects. So in the score that we have in MuseScore, basically there is a concept of a element. So all the things that you see here, these are the elements. Like a note is an element, and its a stem is a separate element, and the bar lines, the staff lines, and the chords, rests, even the score itself, and the text. All of these things, these are the elements on the score. So ideally, what we would have wanted that while making, if we would have written MuseScore, we would probably arrange the elements in such a way like you have the score at the top. It's a basically a kind of hierarchy. So there is a score, and the score has some majors connected to it, and the majors have nodes, and so that's basically and subnodes have like the node have other elements connected to them. Like node can have a dot, it can have a die connected to it. So that's what we wanted in case. So this kind of structure, probably some of you would know this called a tree structure. So it's called a tree because it looks like a inverted tree, somewhat like this. Uh, s- so is it okay so far?
Yeah. It's
Right.
a bit blurry. So the details aren't necessarily the smaller text is too blurry to see. But other than that, we get the gist.
Okay, so I'll just continue. So, in the ideal case, we would have wanted a kind of tree structure to exist, a kind of hierarchical structure within the score. And but the current situation of this code is that you see these links from score to measure and measure to note. These are all going downwards. But in the current situation, it's somewhat like this. Basically, every element is connected to the parent element, but all the links are backwards. You could say so. Like you can go upwards in the tree, but you cannot go downwards. So this is a kind of tricky situation to deal with in the code, and the ultimate aim of my Google Summer of Code project is basically to fix the direction of these links. So we um, in the end, at the end of the Google Summer of Code project, we want to have something like this so that we can be able to traverse the tree from top to bottom. We could start at the score and we'd be able to traverse all the elements and reach each one in turn. So I'll just try to show you uh, how this looks like in a real score. Um, just a second. Um, so what I have done is I've already started to implement one of the ways in which I could fix uh, this kind this problem, and I have created a kind of debugger that would show the tree in this widget right here. So normally when you open MuseScore, you just see this kind of thing. There's the inspector right here on the right, but uh, I've added a new widget. It's called the Score Tree Debugger or whatever you want to call it, and it shows all the elements within the score in a kind of hierarchical way. So you see there's a page at the top. Actually, there's a score. The child of score is page, and within the page there are two systems, and within this system there are some measures, and within the measures there are segments and things like clefs and chords, notes, trills.
Nice.
So
So we can't really read that, but we can
so
see that it gives
that's
a
what
tree
I'm.
structure, basically. And the longer you leave it up, the clearer the text gets. It's like every time it moves, it gets blurrier,
Yep.
but like the longer it stays still, the blurrier it gets. So we have a couple of questions that are coming in here that I'd like you to ask. So one question is, are you inverting the arrows only so that elements can find their parents, find their children, but children can't find their parents, or are you going to keep the parents? So will it still be possible for children to find their parents?
Right. It will still be possible. Basically, you could say that I'm kind of making these arrows bidirectional, so you could go both ways.
That's the question.
But
Yeah.
most of the
And I
improvements
would
in
also,
the code,
I'm sorry, what?
right? Yeah. Okay, so I was saying, most of the improvements in the code would come from the fact that we would be able to traverse the tree from top to bottom, and for doing that, the most important thing is to be able to go from the parent to the children, and going from the children to the parent is not too important actually. Uh, so, so when you want to save the file, it would be possible after this project is completed. We would be able to save the file by doing a single tree traversal. So that means we would go from the top of the score to the bottom, going through all the elements, and we'll be able to save the file in one single function. Whereas currently, there's a lot of code written just for saving the file, and there's separate code for each element right now.
Yes, and that's an important distinction that I wanted to make. It's not that currently a measure can't find the notes within it, or a score can't find the measures within it. It's that every single case like that is handled specially. There's no just general function that allows any element to find all of its children. Every element has to know exactly who its children are and how to access them and in what order. So there's no general purpose function that just knows how to go through things. This, one of the reasons why this ends up being significant is in the way we've implemented the accessibility support and for screen reader support. It requires us to figure out some text that we want the screen reader to display, and we kind of have to pull some tricks on the screen reader to get it to read, not display, but to read the text out loud. What would be much better is if the screen reader was able to understand the structure of the score. So if it actually understood, oh, I'm going from this node, from this measure down to this node, or I'm moving from note to note, and knew where it was in the tree, because screen readers know how to deal with trees like that. So one of the things that could come from this is improved support for screen readers and navigation, being able to use the navigation commands within the screen readers. That's one of the practical advantages. But another one is, I think, what you just alluded to. Right now, just saving the score is just tons of special case code where every single element has to know how to save itself and which of its children need to be saved and in what order. And there's all sorts of bugs that come up where sometimes we have something, oh, it looks great in the score, and then you save it and you reload it and it's different. Those have been tons of bugs that have showed up over the years. We fix them as they get reported, but often those bugs are due exactly to the fact that there's all these special cases and we just left one out. Like, oh, we forgot that this thing needed to write its blah, blah, blah. And if this was all just, if there was one data structure like this tree, then it would simplify that and probably solve a bunch of bugs. That's one of the things that I can see coming from it.
Right. I wanted to also just share an interesting fact. So the first bug that I had solved for MuseScore in December, that was basically the same kind of bugs in which the one you just mentioned, uh, like some images were not being stored correctly when you store them, and when you load them again, they'd just vanish. So I am a bit more familiar with the web development, like HTML and JavaScript kind of things, and I just noticed that in web development we usually never have this kind of code where you have separate functions to write each element. So that was the first time that I noticed that there's some issue with the code.
Yep. One of the other comments that came in here is that the top-down structure here probably matches the structure of Music XML better, which I suspect is true. And Music XML has its own concept of an object tree, which is probably because we do have our own concept of this tree of how things are organized. I know one of your proposals involved creating a separate version of that tree, and then Music XML has its own version of the tree, and that'll be one of the possible complications, is keeping track of the different ways that the tree might need to be organized, right? Did that make sense?
Yep. Um, In fact, I was also thinking about modifying the structure of the tree. Basically, uh, right now the kinds of elements, they are quite disorganized. This is one of my blog posts, one of the first blog posts that I had written, and you can see that some of these classes here, they are not quite well organized. So we could also modify the tree structure in this GSoC project. We could change the way like what is the child of what, and what should be the parent elements.
Also, for people who are programmers, you you might know that, like, if you're dealing with a language like C++, we have it's object oriented, and there's classes and there's subclasses, and so there's a tree of classes. And this is a different thing still, because there could be cases where something is a subclass of another thing, but the representation of the score, that's not a parent-child relationship in how the tree is represented in the score. So there's yet another sort of version of what a tree might mean. So, Kartikay, are there other things you'd like to tell us about the project and where you want to go with it?
Right now, I'd just like to mention that there were two approaches I thought of basically about how we could fix this kind of tree structure. One of them was that since we already have a tree structure, but only the links are kind of inverted. One of the things we could do is we could, as soon as these links are created, we can just kind of capture them, and we could make a list of the links, and we just have a kind of list of children of each element. And that's basically what I've done currently with my debugger right here. So what this is currently doing is, as soon as the link is created upwards, it kind of notes it down, and it creates a list of children from there. So what I have is all of the elements within the score, they are automatically added to the tree, and I didn't have to write any special case for, like, say, handling trills separately or ties or anything basically. All of this I got just for free. But there's a kind of problem associated with this approach, and that's that these elements are not always in order. So, like, this note that it's showing on the top here is actually the bottom note of the chord right here, and this note at the bottom is the top note here. So that's one of the problems with this approach. And so another approach was to write code for each of these classes separately for measure, score, etc. uh, that would avoid the ordering issue, but I'll have to change a lot of classes, so it's a kind of tough decision to make, that what approach we want to go with right now.
The first approach you mentioned, I should also I should clarify the way the tree is structured right now. As I said, each element knows about its children, but it only knows about it in its own special way of knowing about it. But the parent relationship, the fact that we have these pointers going up, the parent, that's the same function, the same member variable parent for every object. So that wouldn't be changing, and that's how those links would stay up. And what he's proposing is that every time we set the parent, that it automatically set its children, which sounds great. It's really easy, but it does mean that then the order of your children is sort of the order. So it would be more like the order you added notes to a chord rather than the actual order that the notes are in the chord. That would be the order of the children. And we kind of need the order to be the same if like navigation is to work reasonably. You want it to navigate in a consistent order regardless of what order you added the things in. Yeah, so I want to post a link. Hold on, go ahead and speak. I'm going to do something. Go ahead, Kartikay. You can talk while I do something.
Right. So one of the other things I wanted to say about this approach was, in both of the cases we'd have to kind of um, rewrite a lot of code. So in one of the approaches, we would have to change like the way set parent function is called. So, like, if we could just change set parent everywhere, and we could actually tell it that where exactly in the parent the measure would like to go. Let's say, like, there's not just we don't just create a link from measure to score, but we actually tell it that this is the first measure, this is the second measure. So that is one of the ways we could one of the ways in which we could fix these links. So in this approach, although I'd have to rewrite a bit more code, but I think in the end this could be a better approach. That's because um, if we could just decide the order of elements from the tree itself rather than looking at some other lists like the linked lists in this code, uh, then we could actually just get rid of all the special cases. We could just keep everything based on the tree itself.
Yeah, that makes sense. One thing I also should mention is each has a mentor, or at least a primary mentor, and there might be other people helping out. The mentor for this project is Peter Jonas, right? I think I have that. Yeah, I'm pretty sure that's correct. So Peter, I've talked about before because he implemented a lot of the accessibility support, or that I've implemented some. Peter's implemented some. I mentored some as part of previous Google Summer of Code projects. But Peter is actually the person who implemented the real-time MIDI input that I mentioned earlier. And so Peter actually first. I think that was his first involvement in MuseScore, was as a Google Summer of Code student. Maybe he had done some bug fixing or something before, but that was certainly his first main introduction to MuseScore, was through the Google Summer of Code. And then he continued to stay involved and continues to be involved, working on a number of things, a lot of them focusing around accessibility. I think I'm not totally sure, to be honest, but Peter, I know Dimitri was someone else I mentioned who worked on some of the internal code structure and then became one of the core developers for a while, and he's sort of moving on now to other projects. But Peter, Dimitri, I'm not sure who else has been a Google Summer of Code student who then stuck around and eventually became a more long-time contributor. But that happens, and sometimes the Google Summer Code students, they participate for the summer and move on, or come back just to fix bugs on their thing. So the Google Summer Code works a lot of ways, but Peter is definitely one of our major success stories from the Google Summer of Code's program. That is my point here. So what else would you like to tell us, Kartikay?
Well, I'm not sure.
Okay. Well, I will, continue to chat for a moment here and see if we get any other questions. But this is kind of exactly what I was hoping to be doing here, is introduce the students and show a little bit about what they're programming. So I want to talk about the process here of the code, because this is also sort of an interesting thing that you might have something to say about. A few months ago, we sort of announced that Martin Curie, aka Tantacruel, it became our head of design at MuseScore, and he has all sorts of like really complex. Ooh, we lost Kartikay. He'll be back. There he is. All sorts of really interesting designs for how to improve the user interface in MuseScore, and so some of his things we've already started doing. Some of them, though, were such kind of major fundamental changes, or required further fundamental changes to the underlying code, that we've decided there's going to be a MuseScore 4, which, maybe was inevitable that would happen someday, but now we know specifically, yes, there's going to be a MuseScore 4 specifically to implement some of Martin's ideas. And we don't know how long it'll be, but let's just say it's probably, more than a month or two, less than a decade. Okay, so some small number of years, hopefully, before Martin's stuff becomes reality. So this all was coming down at the same time that the Google Summer of Code was starting up. So right now we're getting ready to put out MuseScore 3.5, and you've seen me demo, people watching the Café have seen me demo some of its features before. So all of the changes that we're doing, bug fixes and so forth, towards MuseScore 3.5 is like in one version of the code, but just like a couple weeks ago, they kind of made a big split. where now all the stuff that's going into MuseScore 4 is in like a totally separate area of the code that I've not even looked at really yet. But the Google Summer of Code students are some of the first people to be experiencing that. So right now, Kartikay, do you have an actual pull request that you've made on that branch yet, or is it just still trial code so far?
No, it's just trial code so far, and I've just experimented a bit with some of the stuff, and I think I'll create a pull request when we finally decided that which of these two approaches we want to follow.
That makes total sense. And so it'll be interesting because they're making some pretty big structural changes to the code to support some of Martin's design ideas. Meanwhile, the Google Summer of Code students are making their own changes, and Kartikay's is especially sort of a big structural change. So we're going to have a challenge ahead of us, everyone within the project this summer, trying to manage all of that. And while simultaneously getting MuseScore 3.5 released and fixing any bugs that get reported on that. So that's one reason why we were sort of conservative about how many projects we accepted this year. There were lots of great project ideas submitted, and we really tried to be conservative in who we chose and which projects we chose, so that it would have the best chance of success given these major changes that are coming from MuseScore 4. I say major changes, it's not like the program is going to look all that different. Yeah, it will look different, but a lot of coding changes that will be involved, reorganization changes. So you're working, though, on the master branch, is that right, Kartikay? So you're using all the new braces style and all that stuff?
Yep, I just moved to the master branch as soon as the coding style changed.
Gotcha. Okay. Well, I don't know that I have anything more to say other than, we're going to just keep doing this. As I said, next week we'll have Sergio on, and he'll talk about his albums project. Kartikay, do you have any concluding remarks you'd like to share about anything?
Well, not really.
Well, great then. Well, it's been a pleasure having you on, and we're really excited to be working with you. And I'm just so glad to see you working on this project. And I know some of the ways that it's going to benefit us as a project. And I'm just really pleased that that you made that proposal and got selected, and that this is all working out. So thank you.
Right. Thank you too for this invitation and the talk.
Great. Okay. One last question here about so the master in the source is MuseScore 4, yes. But as far as whether there will be a MuseScore 3.6 or 3.7, we don't know. This question's coming in from the chat. It depends on how long MuseScore 4. When we split from MuseScore 1 to MuseScore 2, we didn't realize it was going to be 5 years before MuseScore 2 came out, and so we were not expecting there to be a 1.1 and 1.2 and 1.3. It just happened. And then when we split from MuseScore 2 to MuseScore 3, again, we didn't expect it to take so long. We didn't expect there to be a 2.1, a 2.2, and a 2.3. It just sort of happened. Right now, we don't expect there to be a 3.6 or a 3.7. 3.5 is already going to be a pretty big release. That's not to say that a 3.6 would never happen. No one knows the future. But as of right now, no, I think it's really planned to put full speed ahead towards MuseScore 4, and that will maybe have some better chance of success. The whole way that the MuseScore project is structured now, with the Ultimate Guitar people having actual paid staff working on MuseScore as opposed to just being volunteers. I mean, there's still a ton of volunteers working on this, but the fact that we now have paid staff from Ultimate Guitar who is working on implementing some of these designs, that might cause things to actually move faster than they have in the past. Certainly it helped MuseScore 3 get out the door sooner than it otherwise would have. So I think I will then wrap up with this, and I will see most of you, whoever chooses to tune in next week, when we'll have Sergio as my guest. And again, thank you to you, Kartikay, for joining us today.
Thank you.
Okay, goodbye, everyone, and check in next week. Okay, I suppose I should